Welcome to Study Loop.
Okay, so we have a 20-meter wire, SAB, and it is hanging from a fixed support A, and on the other end is a collar at B. These are both at the same elevation, and point B can move in the X direction, but it cannot move in the Y direction, and we will neglect friction between the collar and the rod that is supporting it. We need to find the force P for which H is equal to 8 meters, which is the sag. So first, we need to find what S is. S is half of SAB, which is 10 meters. And then we also need to find, for the problem, we need to find the corresponding span, which is L. And we need to note that L is equal to 2x. So first thing that we need to do is we need to relate C to Y. We need to be able to solve for C. So our first equation is Y is equal to H plus C. And then our second equation is Y squared minus S squared is equal to C squared. So because we have S, we're able to solve for both C and Y. So because we have H. So first, for our first equation, we need to substitute in 8 for H. So Y is equal to 8 plus C. And now we can substitute our equation 1 into our equation 2. So we have 8 plus C squared minus S squared, which is 10, is equal to C squared. And from this equation, we find that C is equal to 2.25. So now we know that the opposite, in order to make the color hold still, the forces acting on B in the X direction must be equal. So here's our tension. And here's our force P. So we need to give a coordinate system here. So P needs to be equal to the horizontal tension. So the equation for the horizontal tension is equal to our mass per unit length times C. And we're given our mass per unit length of 0.2 kilograms per meter. So, in order to find our horizontal tension, we need to plug in our C that we found and our mass per unit length. And that gets us that our horizontal tension is equal to 0.45 kilograms. Then we need to multiply that by our gravitational factor G, which is 9.81 meters per second squared. So we find that the horizontal tension is equal to 4.4145 newtons. And so balancing our equations so they equal to 0, we know that we need our forces to equal to 0. So we need P going one end minus our horizontal tension. So that shows us that P, the magnitude of P, is equal to 4.4145 newtons. So now we need to find the corresponding span, L, when the sag is 8 meters and when the force is 4.4145 newtons. In order to do that, we need to utilize the equation S is equal to C times hyperbolic sine of X over C, which when we plug that in, we find 10 is equal to 2.25 hyperbolic sine of X over 2.25. As a result, we find that X is equal to 4.94 meters. And because L is equal to 2x, L is equal to 9.9 meters. So just to be clear, we have 9.9 meters equals the horizontal distance between A and B.